What happens when a species still reliant on combustion suddenly holds the power to warp space-time in its hands? In 1988, a sub-facility known as S4 sat buried south of Area 51, isolated against the barren expanse of the Nevada desert. Bob Lazar, recruited as a rapid replacement physicist, was handed a highly classified assignment: reverse engineering the advanced propulsion system of an extraterrestrial craft nicknamed the Sport Model. By stripping away the layers of government secrecy, we can examine the physical hardware itself and the engineering allegedly resting on that hangar floor. At the center of the craft sat a hemispherical reactor. It rested beneath an open dome, fully exposed to the interior cabin. This chart shows the jarring terrestrial retrofit researchers added to the craft. They wired in heavy circular analog pressure gauges to monitor the machine's outputs. They even bridged the alien architecture with vintage glass vacuum tubes. The military was attempting to measure a gravity engine using mid-century electronics. Inside that core sat the reactor's solitary fuel source, a stable, copper-colored block of element 115. The machine operated in silence. It had no exhaust vents, generated no combustion, and contained zero moving parts to produce thrust. A device operating without reaction mass or heat transfer defies the laws of thermodynamics that govern human engine design. To lift the craft without traditional thrust, the reactor had to manipulate atomic forces internally. Hidden inside the device was a miniature cyclotron, a mechanism resembling the heavy metal particle accelerators used in terrestrial physics labs. This accelerator bombarded the element 115 core with targeted radiation. This diagram shows a bombarded nucleus. The reactor targets the strong nuclear force, the binding energy holding it together, forcing it to pulse and expand. As the reaction scales up, it projects that force beyond the nucleus, converting it into an elastic, localized gravitational field. Because the nuclear decay powering the electronics also creates the propulsive force, the battery and the engine are the same event. That microscopic atomic reaction produced physical, macroscopic effects in the lab. To test the anti-gravity field, a researcher wearing a heavy utility glove pressed into the visible refraction of air surrounding the core. The glove hit an impenetrable barrier. At exactly 9 inches from the core, the field resisted the hand with an elastic pressure. Yet despite projecting enough repulsive force to stop a human arm, the reactor exerted zero downward pressure on the floor beneath it. Rather than displacing air to create lift, the field cancels its own mass, isolating the machine from the Earth's pull. In 2003, human scientists officially synthesized element 115, now known as Moscovium. This chart shows the relationship between time and atomic mass for lab-grown Moscovium. It decays almost instantly. But further right lies the island of stability. Here, nuclear physics predicts a heavier isotope could remain stable, matching the solid core Lazar described. The fact that we can only create volatile atoms highlights the distance between our current reach and the properties of a stable superheavy element. This theoretical gap marks the limit of human particle physics compared to the alleged capabilities of the S4 hardware. A stable element 115 reactor presents a direct threat to modern power dynamics, bypassing the fuel and friction constraints that define every human craft. In a localized gravity environment, heavy industrial platforms and traditional defense systems would become completely and instantly irrelevant. How could humanity safely steward a technology that pulls the fabric of space toward itself?